Welcome back to the channel, guys. So in last video we discussed about collections in Java. So in this video we will be discussing about certain advanced concept provided by the Java for the users. So what are these advanced concept? Okay, so they are generics, Lambda expression, and stream APIs. So what are generics? So they provide type safety and code reusability by enabling classes, interfaces, and method to operate with the type specified at compile time. So what does this mean? So as you guys will be aware, like they are certain primitive data types provided by Java, such as integer, boolean, string, certain like that, right? So what are generics? So generics are general data type. You can assume they are general data type. So basically, what if I say, like, if I tell you guys to write a calculator program, so you guys will be writing obviously a class, and inside that you will be writing around 4 to 5 functions. So 4 to 5 functions. Why? In the sense, like, one function will be doing the functionality of addition, and the other will be doing the functionality of subtraction. Similarly, multiplication, division, and modulus, right? So what if I tell you that this 4 to 5 functionality can be replaced with single function, right? Sounds good, right? Yeah, it's possible in Java. So here we'll be using the concept of generics. So generics in the sense is that, so as you know that there is certain functions, right, inside which you will be calculating the calculate, right? So for that, what if I tell you, like, a T, a capital T can be replaced in the signature of the function in the space where you will be declaring the data type. So in the space where you will be declaring the data type of particular variable, you can replace that particular data type with T. So the compiler will come to know. So this is a generic type. So this is a generic type. So I need to assign a data type for this particular variable at the compile time. So when we'll compile the program, at that time, a particular data type will be assigned to the variable based on the user input. So if I say I need to add two integer, I will provide two integer, and the compiler will come to know, okay, this is integer. So I need to assign integer value to the particular t variable or t keyword, anything, t keyword, which will be declared in spite of the data type, right? That's the thing here. Similarly, if the user prompts for a double value, obviously double will be replaced at the compile time. Yeah, that's the use of the generics here. So a more of code reusability in the sense, that's what I told, right? A single function can be used to accomplish whatever 4 to 5 functions are performing. So coming to the lambda expressions here. So what is lambda expression? So this introduces a concise way to represent anomalous functions or closures. Okay, what are these anomalous functions? So anomalous functions are nothing but, if you are guys, like, you're aware of JavaScript, there are anomalous functions there. To put it in simple words, these anomalous functions are nothing but functions with no name. That's simple as that. Obviously, you will be knowing, like, they are functions, and the functions has a return type, and it has a function name. It upset the signature, it may not upset signature, and there is a return type, or they may not be a return type, right? You guys will be knowing this type of function. So they are exactly the function, same function, but a variety of functions. So what is the variety? These functions will not having a function name. I will show how the syntax and all, no need to worry. So they allow you to treat functionality as a method argument or to create concise anomalous function. So functionality as a method argument in the sense is that, so the focus is on declarative programming here. So what I mean by the declarative program here in the sense is that, so declarative program is a programming way where you will be more bothered on implementing the code rather than how it will be implemented. You'll be bothered on the implementation of the code rather than how you gonna implement it. Meaning that how I will implement it, what name I will give it, what will be the return type, rather than thinking all this stuff here. Just I will write the code, right? Just I will write the code, and I will forget about the function name here. No need to think why I need a function. I'll just call the function wherever it's required and do the functionality, right? That's what this line mean here. and stream API. Coming to the stream API, so API in the sense is the full form of API is application program interface, right? Okay, so here stream API provides a fluent way to process collections of objects in a functional style. Okay, obviously we have studied about objects and we know what the collections are. So the collections of object, we know what is collections, right? We have studied about collections here. So what if they are collections of different objects, right? How to manage them, right? For that obviously we will be using streams. They enable operations such as filtering, mapping and reducing on streams of elements. Okay, what are the streams, right? That's the first thing which comes to our mind. Stream API, what are stream, right? I will tell that. So keep these three terminologies in mind: filtering, mapping and reducing. I will explain about that in coming part. Okay, on streams of elements, let's see what the streams of elements are. So before that, let's jump into the generics coding part here. Yeah, so this would be a perfect example. Yeah, so here if you guys will see that this class upsets a type, right? As I was mentioning, the T, a capital T within this arrow marks, right? So this T is even upsetted at this particular data type. So this is normal variable declaration, where this is the access specifier or modifier, and this is the data type of the particular value variable. Okay, and this set value, get value, these are setters and getters. Okay, and they tag, like they are taking the signature as type T, and this T is declared at the class level. So everywhere this T will be in the scope here. Okay, inside this class this T will be in the scope. So let's import this class in main method here. Okay, let's import the class by the constructor name box. Okay, by the constructor name, and this is the syntax, guys. So whenever you are using the generics, like this is a must, we need to specify to the compiler that I am using the generics concept, so I am using this arrow marks. Okay, so this is the particular constructor which will be invoked, and I am storing that in a double thing. So this automatically will be assigned double, right? This T or whatever generics type data type is there, it will be assigned to double at the compile time. Okay, so this variable or whatever you will say reference I'm taking and calling the set value method inside that. So if you go to the box, there is a set value method which takes an argument, right? So I'm passing an argument here of the type double. So I'm prompting that to the console here using the get value method of the reference variable. Okay, so let me just run this. So if I run this program, you can see that I am getting a value of 10.5. So let's go and make it 10. Obviously it need to get printed. So there's a catch here. Let's make this an integer, right? Let's make this as integer. Okay, yeah, there is an error here. Why there is an error? Because I am the method set value is type box integer is not applicable to argument double, right? So double can store integer, but integer cannot store double. These are basics which I have explained in the coming series. So if you guys are following, you guys will be knowing why this error we are encountering here. Obviously in the double we can store integer, but in integer we can't store the double value. Double value in the sense the floating value or the decimal point value is not possible to be stored in the integer. Okay, that's the reason we are encountering this error. So let me make it an integer by passing the value 10. Okay, it's taking, let's just run this. Yeah, we got the value 10. So I think it's simple, guys. Generics are simple. Like if you want to make it as a string, we can make it as a string, and obviously we need to pass the value in the double quotes here. Let me make it as string and pass a double quotes telling hello world, right? Hello world. Let me tell hello world. Let me quickly run this. We got the value as hello world. Simple, guys, nothing complication here. Generics are simple, I guess. So Let's go to lambda expressions. Okay, the same function, right? In the same function, main function, we will see the lambda expression. Okay, so what are lambda expression, how they are different from the normal function? Let's see that. So normal function, where we'll be having return type and we'll be having the access specifier in the sense, and also static. I told like static I have explained. Please follow the previous series so that you will get to know the keywords here. So this is a function which takes two arguments. So the arguments are of type integer here, and it returns the value by multiplying those two arguments a and b, and this function name is multiply. Okay, super. So how this is different from lambda expression? I told lambda expressions are also known as anomalous functions. So anomalous function in the sense they will be not having any names. Okay, okay, let's see that. So here, this one arrays as list. Arrays like it's an inbuilt method in the util class. So what we are taking here is that we are taking an array and we are converting it as list. As list is the function which converts array to a list. So we're taking an array and converting it to a list, and we are inserting these values. Okay, 1 2 3 4 5, and we are storing that list of integers. This is generics, I told, right? This is generics here, list of integers inside the variable numbers. Okay, and here if you see, I am taking that numbers variable and I'm applying a stream operation here. What is this stream operation? Yeah guys, this stream method is there, right? So this like if you guys remember previously when I am talking about streams, I mentioned like there are three particular terminologies which are essential. So map, filter and reduce, right? In order to apply these three functions, map, filter and reduce, we need to convert a variable which is of primitive data type to a stream type. Stream type in the sense, to be precise, it will convert the integer to an stream integer, or floating point integer value or double value to an stream double value. Similarly, a string value to a string value, right? In order to do that, we need to call stream method on the variable name. That's all. Okay, that's what we are doing here. For this list of integer, we are converting this as an stream integer by calling the stream method. On this stream method, we are applying the map function. Okay, so what does this map function will do is that it will iterate to each and every element present in this list integer. Okay, so it will iterate to each and every element present in this particular integer and perform an operation on that. Okay, we can perform an operation on that. Let's see. Let's see the syntax here. What's the syntax here? In the sense n. Okay, so this is the particular lambda expression which I am talking here. So this is an arrow mark. So this is basically a function here. Okay, whatever we are doing here, we are multiplying here. What we are doing is that we are multiplying a number by 2. So it's similar to like that. So we can also do like this. We can take this argument in n. Okay, and we can put this inside an flower bracket to tell it's an particular function. Okay, it's as simple as that. So since it's a single line, we'll not be doing those things. If it is multi-line, obviously we need to do that. So if there are more than one argument, we can take parentheses here. Now it's not required. So this particular n will be having 1 as a value at a particular time, 2, 3, 4, 5. These are the values which will be given for this n. So this is identical to for loop. If you guys remember, for I is equal to 0, I is less than n, I plus plus, and I will be having the value of this any array values, right? Similar to that, I will be having value 1 2 3 4 5, and for that it will multiply by 2 in the operation. Okay, you can remember like this. Inside a function, like it's a function, and this is an arguments of the particular anomalous function. Since there is no name for this function, we call this by anomalous function. Okay, still any more operations can be present, like that. So that's the work of map here, guys. So that's the work of map here. It will take an arguments, it will perform operation on the particular argument. So dot collect will collect the output from the map function and will convert to that to a list, convert the map stream or stream integers into a particular list elements or to list. So it will take a list, new list, and add the output of the map to the particular list. Okay, that's what this is doing. If you want, you can also prompt this and print to the console dot to list. Let me print the double to the console. So let me just copy this, control V. Let me print value of the doubled. Okay, we'll run this. I think it should be commented, sorry. Yeah, we can see, right? Each and every element value has been doubled because it's been multiplied into 2. So 1 into 2 is 2, 2 into 2 is 4, 3 into 2 is 6, 4 into 2 is 8, 5 into 2 is 10. That's what we got here. We are printing that to the console. Okay, that's the concept of lambda expression. So let me now jump to the stream example here. I told, right, as list will convert arrays to a list, and it will store a list of string values because we are storing at the initialization time string values here. Okay, there are 1 2 3 4 5 names being stored in the sample data. Okay, so to convert to a string, as I told, like we need to use stream method. So we'll use a stream method, and so that we can apply map, filter, and reduce functions. So what filter will do? Filter will filter out the data. Okay, it will filter out the data based on the condition which we give. So this is an anomalous function here again, once again. So this anomalous function doesn't have any name, and it takes name as the parameter, and for that name it will do a particular operation here. So let's see what's that operation here. So in the sense here, there is an Alice, there is a Bob, there is a Charlie, there is a David, and there is an Eve function. So what does this will do is that for the particular value present in the particular list of strings here, which is a converted stream of strings, okay, it will filter out based on this particular condition. It will select only names which start with C. Okay, if the name start with C, it will select that and it will convert that to an list dot to list. So that will be stored in this particular name start with C. So if I prompt this the console, we need to get only Charlie. That's the filtering or filter method does for us. Okay, let's see the map functionality we have already seen. The same example, on the names it will convert to string and it will store in the particular variable. On for that variable, we are calling to uppercase method which is present in the string class. Okay, so it will convert all the uppercase names variable values to the uppercase, and we are converting that to list, so that we will be having a particular list of uppercase names. Okay, and here reduce function. So what does reduce function or reduce anomalous function does here is that it will obviously is an anomalous function with no name. It will take as many as argument it's want, and it will perform whatever operation we need. Okay, in our case we are performing concatenation operation, which is nothing but combining two names, concatenating all names into a single string. That's what we are doing. For every names we will be converting it. Let me print it so that you guys will be understanding this. So there are also certain built-in functions which are present, such as sorted. We can use to sort. Okay, we can compare two names and reverse them, sort names in reverse order. That's what we are doing. And we can also use the count. Okay, a count function which is present to count the number of names present in particular list. If 5 names are present, it will prompt 5 as the output. And we can also find the first name which starts with A. So these are certain functionality examples here. So if a name starts with A, that can also be filtered. That's simple example here. And we can also match a particular letter or character present. Okay, that's this case. You can go to same example, guys. Just the functionality or whatever you say, operation differs here. Here we are selecting names which start with B, and here collect names into a single string separated by commas. So we are using joining operation. So what we are doing is that we are collecting all the names into a single string separated by commas. So for example, we are converting this particular names to a stream. Okay, and on this stream of strings we are applying collect method. Okay, and java util stream dot collector, this is the joining is the particular function which you are targeting, and we are combining that. If I prompt to the console, I think it will be useful. So here if you see, for the first case we are getting Charlie as the answer. That's correct. And for the second thing, obviously uppercase, right? Uppercase, everything is in uppercase. And concatenated names, you can see Charlie, Bob, because we are concatenating everything and printing it. That's all, right? We're doing the same thing into a single variable, which is an optional. Here optional in the sense it can be of anything. As I told, it can be anything. Optional in the sense like at the runtime, if it's not a string, it is anything, obviously it will print. That's the optional. You can Google on that if required. So here concatenated names, we are getting a single variable value we are printing here. And reverse, we are applying reverse method. This we are taking two arguments, comparing that with the first one, we are converting the list. Okay, that's what we are sorting here. Okay, yeah, the count is 5 as I told. If there are 5 names, more than one names, it will be obviously incremented or decremented. So find the first name that starts with A. Yeah, life is there. Which starts with B, Bob. Obviously there is a Bob, so we are printing a boolean value, I guess. So if we name that starts with B, any name that starts with B, so any match will return a boolean value. That need to be kept in mind. Any match will return a boolean value. If there is a match, it will return true. If there is no match, it will return false. Okay, so collected names, as I told, right, we are collecting names into a single string separated by comma. So this is a single string, and we are obviously joining them based on the comma. Okay, I think that's all, guys. So I think I covered the advanced concept which are by far enough for our full stack thing. So if you guys required videos on file handling and threads, multi-threading, please do comment down below. I think in this particular course it's not required. In terms of academics, if it is required for you guys, obviously I will make a video on that. No issues from my side. So I think we'll be starting with SQL, I guess, probably, or we'll directly jump to Spring Boot. You guys decide on that. So either Spring Boot will start, or we'll start with the SQL. I think SQL can be finished within 4 to 5 days, I guess. So you guys decide and comment down below. So thanks for watching, guys.